with the 8.3, this is when you are adding and subtracting rational expressions. So sometimes it will have a like denominator, sometimes it will have an unlike denominator, and those, honestly, those two sections that we have, I don't think y'all are going to struggle with as much as when we have complex fractions. Okay, the complex fractions is the one that we typically see a lot of struggling with. Okay, so I want you to think just back to normal fractions that you would see like in elementary and middle school. Okay, so if I have something like 1/5 plus 3/5, can I add that? Yeah. What makes it to where I can add it? Common denominator. So if I have a common denominator, then what does that give me when I add 4/5? Okay, so you add the numerators and it just goes over that same denominator. That is the same case when you have rational expressions. Okay, so if I'm looking at my first example and I have 9x cubed over x plus 1 plus x squared over x plus 1. Okay, I can tell that I have common denominators. Okay, so I know that I can add those numerators and put it over that common x plus 1. So when I add my numerators, that just becomes 9x cubed plus x squared, right? Okay, and then we always check, can we simplify? So my numerator, if I have 9x cubed plus x squared, can you do anything with that? You can take out an x squared. If I factor out an x squared, that leaves me with 9x plus 1, and then my denominator is x plus 1. While I might not be able to cross anything out, that is my simplified factored form. Okay? So when you have common denominators, you literally just add the numerators and simplify. Okay? So we'll do one more example in this section. There are 3, so if you feel like you need extra examples on this whole note, okay, look in the Google Slides for my copy of the notes, and I have every single example that we might skip. Okay? So my next one is if I have 2x squared over x squared plus 1 plus 2 over x squared plus 1. What would that give me? 2x squared plus 2 as my numerator, all over that x squared plus 1 denominator. Okay, then I would see, can I simplify anything? I could take out a 2 as my GCF, and that would leave me with x squared plus 1 over x squared plus 1. Now, do you recognize anything? You can cancel out the x squared plus 1, and that leaves me with just 2. Okay, so when you have your common denominators, it's just that simple. There's no added complexity to that. Yes.
How come you would split the x squared plus 1?
That would be, that's because it's the sum of two squares. If you would have had x squared minus 1, then you could have factored that into the difference of two squares. But the sum you can't factor further. Okay. All right, so there is a third example that if you need it, you can look in the Google Slides. Okay, but we're gonna move over to unlike denominators. So if you think back to normal fractions, if I have 1/3 plus, let's say 4/9, those are not common denominators. So what would I have to do? I would need to multiply 1/3 to become a 9, right? My common denominator would be 9. To make this 3 a 9, you'd have to multiply by 3. What you do to the bottom, you have to do also to the top. So that 1/3 is going to become what? 3/9 plus 4/9. Now that I've got common denominators, then I can add 7 over 9, right? So sometimes you only have to manipulate one fraction to get a common denominator. But then there are other times where, say I have 2/5 plus 5/3. Okay? I can't do anything with 5 and 3. So if I need a common denominator between 5 and 3, what could I make it? 15. If I know that they need to become a denominator of 15, then what am I going to have to do? Multiply the first fraction by 3, because the factor of 3 is what it's missing to get to 15. And then the 5/3, I'm going to have to multiply by 5. So you just multiplied the two by whatever factor they were missing to get the common denominator. So then that becomes 6/15 plus 25/15. And when you add that, you get 31/15. Okay? So my whole goal is to make sure you understand the concept of how you get that common denominator. Okay? By multiplying whatever you need. Okay? So when we have unlike denominators with rational expressions, okay, you are going to have to look at your denominators and find a common denominator between those, and then you multiply about whatever you need, just like we did here. Do all the simplifying you need to add, okay? So finding your LCD, which your LCD is your common denominator, your least common denominator, okay? Finding your LCD with your numbers, you're going to find the highest common factor, just like with 5 and 3, I found 15. Okay? Now, with your variables, that's something that you have to know. Your variables will be your highest exponent with the variable. So if I have an x and an x squared in my denominator, I'm going to choose x squared. I want the higher one. Okay? Your common factors, if I have something that's in both, then I just write it once because it's already common. Okay. So for this first section, all we're doing is finding the LCD. We're not actually solving. Okay. So originally there's 4 problems in this section. We're probably going to just do 2. So we move on to actually solving it. Okay. So if I have, let's say my first example, I have x minus 1 over x minus 4 minus 2x plus 3 over x squared minus 6x plus 8. Okay, if I'm looking at that, what do you notice? Yes, I need to factor this denominator. Okay, so whenever I factor it, I keep my x minus 1 over my x minus 4, and I subtract that 2x plus 3. Now, because of time's sake, I'm just going to tell you what factored form is, but hopefully you can follow me, okay? Factors of 8 to give you a negative 6 would be x minus 2 and x minus 4. Okay, so if I'm just trying to find a common denominator, what do you notice between those two denominators? They both have x minus 4. That's what I mean by common factors, you only write it once. If I have x minus 4 already, it's already common, so it has to be part of my common denominator, but I only write it once. Okay? And then, notice I have an x minus 2 still. I need that to be part of that common denominator. That would be my full common denominator. Okay? So let's say I have 4 over 5x minus 5 minus 3x minus 4 over 6x minus 6. Okay? What can I do with the 5x minus 5? Take out a 5 as a GCF, and that leaves me with x minus 1. Minus that 3x minus 4, and then I can take out 6 as my GCF, and that leaves me with x minus 1. Okay? So if I'm just finding a common denominator, what do you notice? I have x minus 1 in both. So that's already common. It's going to be listed as what I need. Then I need to look at that 5 and that 6. If I have a 5 and a 6, and you can't really visualize it because you have a whole lot going on, imagine if you just had 1/5 and 1/6. Okay? If you get to where your numbers and you can't figure out what you're doing, just bring it back to this. 1/5 and 1/6. What would I need for a common denominator here? 30. So that's what is part of this common denominator. That 5 and that 6 needs to become a 30 to be a full common denominator. Okay? Are we good with that? You understand that? Alright, so that is just getting you to understand how to find the LCD. Okay, so our next section, we are going to actually do the problem. Okay, now the original copy of notes has 6 examples in this section. We're not going to get to all 6. Okay, so we're going to look at a basic and a kind of medium, and then a little more complex, and then see how y'all are with that. Okay, this section, honestly, I don't feel like you're going to struggle with. It's the complex fractions that I'm more concerned with. Okay, that's the hardest part of this. So if I have my first example, I've got -3 divided by x plus 7 plus 11 divided by x minus 4. Okay, now I have to state my LCD on every single problem that I do. Okay, so if I'm looking, x plus 7 and x minus 4 are not common at all. That is like when I did my 1/3 and 3/5 or whatever you called it. Okay, so when I had the 1/3 and 3/5, I had to multiply them both, right? I had to find a common denominator between the two and multiply them both. That's like what this is. Okay, so if I need to find a common denominator between x plus 7 and x minus 4, I'm just going to put the two together, and it's going to have to be x plus 7 and x minus 4. That's what I want my denominator to become. Okay, so if that's what I want my denominator to become, if I'm looking at my first fraction, what do you think I need to multiply it by? Okay, so if I'm comparing what I have, so only look at your first fraction. I'm comparing what I have to what I want it to be, right? Because your LCD is the common denominator that you want. So if I want it to be this, what am I missing? X minus 4. That's what you're going to multiply by. So remember, what you do to the numerator, you also do to your denominator. Okay. Now this second fraction, my denominator is x minus 4. If I compare that to what I want it to be, what am I missing? So that's what I'm multiplying by. Does that make sense? Okay, so you are multiplying by whatever factor you're missing from the common denominator. Okay, so that makes it this first fraction. I know my whole point of multiplying is to get the common denominator of x plus 7 and x minus 4. All right. Now my numerator, I am multiplying -3 times x minus 4. So I take that -3 and multiply it by x, and that gives me -3x. And -3 times -4 is going to give me a positive 12. Y'all follow me so far? Okay. Then I have my plus. Now, this second fraction, again, I know my whole purpose of multiplying was to get the common denominator of x plus 7 and x minus 4. Okay? When I multiply 11 by x plus 7, I do the same type of distributing. 11 times x is 11x, and 11 times 7 is 77. Have I created common denominators? Yes, so that means I can join and add my numerators and put it over that one common denominator, x plus 7, x minus 4. So when I add my numerators, I'm doing my like terms. What is -3x plus 11x? 8x. What is 12 plus 77? 89. Okay. Then I would see, can I simplify? I cannot take 8 away from 89. I cannot take 2 away from 89. I can't take 4 away from 89. So this is going to be my answer. Okay, a problem like that, I think, is doable. Okay, do y'all see the process? Okay, so then if I have my second example, let's say that I have 3 over 10x squared plus 2x over 5x squared minus 10x. I can take out a GCF in my second denominator. Y'all see that? Okay, so I've got 3 over 10x squared plus 2x. What is my GCF between 5x squared and negative 10x? 5x, good. And so that leaves me with x minus 2, because you're dividing by 5. Okay, so between these, I need to find an LCD. I need to find my common denominator. Okay, if I start with the beginning, I have a 10 and a 5. If I had 1/10 and 1/5, what would I need to make it? A 10, right? So if you need to write it, 1/10 and 1/5, you could make that 5 a 10. Yes, we all see what I'm doing.
Yeah.
Okay, so 10 is going to be part of my common denominator. Then I'm going to look at my x's. I have x squared and I have x. My rule says with variables, you take the highest exponent. So that means I'm going to take the x squared. And then all I have left is that x minus 2. I have to include that. So 10x squared, x minus 2 is going to be my common denominator that I want to create. Okay? So if that's the common denominator I want to create, I'm going to look at my first fraction. If I compare 10x squared to 10x squared times x minus 2, what am I missing? X minus 2, so that's what I'm going to multiply by. Okay? Now when I look at my 5x and x minus 2 as my denominator, my x minus 2 is already there, so I don't need to multiply by that. So see how I need a 5x to become a 10x squared? I can multiply that by 2x. Do y'all all see that? Okay. So, now my two fractions, my denominators are my 10x squared, x minus 2. And then my numerator, I'm multiplying 3 by x and negative 2. So that becomes 3x minus 6. Plus, my denominator again becomes 10x squared times x minus 2. And then my numerator, what's 2x times 2x? 4x squared. So now I have common denominators. I can combine my numerators and put it over that denominator. What do you notice with your numerators? When I go to add that, what do you recognize? It's going to be a trinomial. So instead of me just writing 3x minus 6 plus 4x squared, I'm recognizing it's a trinomial. I want to put it in standard form to prevent me having to rewrite it one more time. Okay? So if I know it should be in standard form, that 4x squared comes first, then plus 3x, then minus 6. Yes, we good with that? Okay. Then we would see, can I factor? All right. If I try to factor, I would have to multiply first times last, right? Because I have a coefficient greater than 1. That gives me 24. Factors of 24 to give me a 3. Well, my factors are 1 and 24, 2 and 12, 3 and 8, then 4 and 6. Would any of those combinations give me a 3? No. So I cannot factor it. That would be my answer. Good with that? So then let's say we look at x minus 4 over x plus 4, x minus 2, minus x plus 2 over x squared minus 16. What do I recognize? I got the difference of two squares here. So I'm going to rewrite that, x minus 4 over x plus 4 times x minus 2, minus, I have my x plus 2. What is x squared minus 16 factor to? Good. X plus 4 and x minus 4. You should all be very good at identifying the difference of two squares and knowing you're essentially taking the square roots with those numbers. Okay. So now we need to create our common denominator. So we need our LCD. What do you recognize between those two denominators?
Plus 4.
They both have x plus 4. So do I write that twice?
No.
Just once because it's already common. Then I need to include the other ones. So that means I need to include x minus 2 and I need to include x minus 4. Now the order of which you write it doesn't necessarily matter. I could have x plus 4, x minus 4, x minus 2. I could have x minus 2, x plus 4, x minus. That doesn't matter as long as you have it all there. Okay? So if this is my common denominator, now look at my first fraction. I have x plus 4, I have x minus 2. What am I missing? That's what I'm multiplying by. So then look at your second denominator. What am I going to multiply the second fraction by? X minus 2, because that's what I'm missing. When y'all are doing your work, notice I'm writing it to the numerator and denominator. I need to see that on you also, on your work. Because if you just multiply by x minus 2, technically, that's not what this is equivalent to whenever I multiply. Okay, so it has to be numerator and denominator. Okay, or that will be a point off if you don't actually have it written properly. Okay, because there's a big difference there. So now I'm going to have my full x plus 4, x minus 2 times x minus 4 as my denominator. When I multiply my numerator, I have two binomials. That means I need to FOIL it. Okay, so x times x gives me x squared. Then I have x times negative 4, negative 4x. And then negative 4 times x is another negative 4x. And then negative 4 times negative 4 is 16. Then I have minus. Again, my common denominator, x plus 4, x minus 2, x minus 4. And then I need to multiply x plus 2 and x minus 2. Yes, those are conjugates. Okay, now if you need to FOIL it, you can. X squared, you'd get a negative 2x plus 2x, so those two would cancel. So it just leaves you with x squared minus 4. Okay, so what I'm going to do now is combine all over one common denominator, x plus 4, x minus 2, x minus 4. And I'm going to be very careful whenever I combine my numerator, because if you notice, those first two examples had a plus. This example has a minus. You have to be extremely careful with subtraction. Okay? That means you are subtracting that x squared and you are subtracting that negative 4. So you are essentially distributing a negative. Okay? So do not forget, when you have a minus, you are distributing that negative to everything afterwards. Okay? So I'm going to have x squared, negative 4x minus 4x is a negative 8x, plus 16. Then I'm going to have a minus x squared minus a negative turns into a plus 4. Okay, now some of y'all are going to get in the habit to where you can combine it all and miss this step. But for right now, we're going to write this step because I need you to see it all at once with the sign changes. Okay. Now, when you go to combine like terms, x squared minus x squared is going to cancel. And so I have a negative 8x plus 20 divided by x plus 4, x minus 2, x minus 4. Okay, can I do anything with that?
Take out
What can I take out?
a 4.
Okay, notice you have a leading negative also, so I can take out a negative 4. Okay, so that would leave me, if I take out a negative 4, I have what? What's negative 8 divided by negative 4? So I have a 2x. What's 20 divided by -4?
Negative.
All over that x plus 4 times x minus 2 times x minus 4. I can't cancel anything out, so that's my answer.
Okay, so on the x squared minus 4x minus 4x, when those both combine, why would we like have to put the trinomial?
So, like, why do I not
Combine
go
it.
from here? So I'd be going back to this. So I'm
Oh.
trying to combine my two numerators. So I don't want to put it back in factored form because then I'd be just back and
Okay.
forth and back and forth. Does that make sense?
Yes, ma'am.
Okay. So, do we understand so far? Okay. I would like to do one more example just to make sure y'all have it. Okay. Let's say that we do. I'm gonna let y'all do this one. X plus 2 divided by 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3. Okay. I want you to talk me through. What's my first step? Factor the denominators. Okay. So some people miss that first denominator can be factored. It's not a trinomial, but I can factor what? A 2. I can factor that GCF out, and that leaves me with x minus 1. Minus, I have my negative 2x minus 1. What does that denominator become?
X minus 3.
X minus 3, x minus 1.
They're both negative. X minus 3, x minus 1. Okay, so I want you to look at it. What do you think your common denominator needs to be? Okay, good. So that x minus 1 shows up twice. It's already common. The 2 I need, and the x minus 3 I need. So if you have a constant or one term like a x or something like that, that comes before your binomials when you write it. Okay, that's the proper way to do it. So this is my common denominator. What am I multiplying the first fraction by? Okay. What am I multiplying the second fraction by? 2. Now I'm cramming that because of my space, but you're multiplying with me. So what I'm going to do in this step is I'm going to already put it over one common denominator because I know that's what I'm doing. That's my goal anyways. So I'm going to have 2 times x minus 1 times x minus 3. That's my common denominator. Okay. When I multiply x minus 3 and x plus 2, I FOIL that, right? So x times x gives me x squared. I'm going to have a 2x minus 3x. What does that give me? I got a positive 2x minus 3x. So that'd be a negative 1x, right? Yes? All right, then negative 3 times 2 is a negative 6. Then I have a minus, and I am multiplying 2 times negative 2x and negative 1. So 2 times negative 2x. 2 times negative 2x is what? Negative 4x. And 2 times negative 1 is negative 2. If all I did was write it like this, is that correct?
Why? It's combined.
Well, before I combine, what's incorrect?
You have
Your 4x.
Okay, why did I need parentheses around that 4x minus 2?
Your 4x.
Okay, now, if I'm looking at this, is this really a 4x? No, I had 2 times negative 2, so I had minus a negative 4x minus 2. You have to be careful with that, okay? Now I'm going to distribute that negative. So I've got my 2, x minus 1, x minus 3. I've got my x squared. Now when I distribute this negative, that becomes a positive 4x and a positive 2. So when I combine negative x plus 4x, that gives me 3x. Negative 6 plus 2 gives me negative 4. Y'all follow me? All right, can I factor? Yes. That numerator can factor x plus 4, x minus 1. And I have 2 over x minus 1, x minus 3.
Why did you put the 4x in parentheses again?
Because you are subtracting whatever comes afterwards. So if all I'm looking at is 2 times negative 2x and 2 times negative 1, that gives me a negative 4x minus 2. But I'm subtracting that off.
Oh, okay.
So I have to be careful. If I don't do that, then my signs and my numerator are going to be wrong. Okay? So if I get that, then what do I need to do?
Can cancel out.
I can cancel out. So that leaves me with x plus 4 over 2 times x minus 3. You understand that? Alright. We're going to move on to complex fractions. Okay? Complex fractions are when you have your numerator as a fraction and your denominator as a fraction. Or one of those is a fraction. Somewhere you have a fraction within a fraction. Okay? So this is where we're going to look at a super simple example and then we're going to build. Okay? So with just numbers, if I had 1/2 over 3/4. Okay? Now, I understand that you could do keep, change, flip here, but I'm trying to get you to see how to operate with complex fractions with a common denominator, okay? So, with a common denominator, I need to look at just my little denominators, right? These are like my mini ones, okay? These are my fractions within a fractions, and I'm looking at those separately. If I have a 2 and a 4, what could my common denominator be? 4. Okay? So what that means is I need to multiply my numerator by 4 and my denominator by 4. So you're going to treat complex fractions different than what we just did. Okay? What we just did was we multiplied separate fractions by what we were missing. Here, we're looking at multiplying the full numerator and the full denominator by that computing. Okay? So if I'm taking 1/2 times 4, okay, so I'm separating it so you can visualize what's happening. That 4 is really only going to the numerator, because really this is 4 over 1, right? If you set it up like that, I want you to see that that 2 and 4 can cross simplify, right? That can go to 2 and 1. So when I'm doing this, the whole purpose of multiplying by the LCD is to cancel that numerator, that denominator of the numerator out, and this becomes a 2. I know that's a whole lot of jargon. Okay, so I'm going to re-say that. Okay, if you cover this up and I just separated All I did was 1/2 times 4. Okay? We can recognize when it's written like this, we notice it can cross simplify, yes? Okay. So when you do complex fractions, you are multiplying the full numerator and the full denominator by that one LCD. And what that is going to do, the reason being is it's going to cancel this little bitty mini denominator and it will cross simplify with this. Okay? So 1 times 2 is what? 2. Alright, now if I look at my denominator, I'm doing 3/4 times 4. What happens? The 4 cancels and I just have a 3. So my answer is 2/3. Okay? It takes practice with complex fractions. Okay? The whole thing that should be happening is those 2 little mini denominators that I keep calling should cancel out. If they don't, then you don't have the right LCD. Okay? So let's say that I have no, we're gonna do this example. 2 over x divided by 5 over x. What's my LCD? X. So I'm going to multiply top and bottom by x. Okay? Now I'm going to cover up my bottom so I can only focus at one at a time. Those x cancel, leaving me with 2. If I look at my denominator, what happens? X cancels. I have a 2/5 is my answer. Okay? Now these are like baby problems compared to what we're about to do. Okay? But I want you to get the gist of that, okay? So if I give you, let's say, x minus x over 4 divided by 2 plus x over 3. And I'm just trying to find the LCD. I'm trying to find the common denominator. You are looking at your baby denominators, right? Your little mini ones. What are my mini denominators? 4 and 3. We all know what I'm talking about when I say that, right? Okay. So between a 4 and a 3, what could my common denominator be? All right. Step 1. You can do step 1. You can find a common denominator. Okay, that's all we're doing right now. Okay, so if I give you 10 over x plus 1, and that is divided by 3 over x plus 2 over 5. Okay. What do you think your common denominator is going to be? She said 5x and x plus 1. Good. All we did was look at our mini denominators and we put them together. Okay? All right? Okay. Now we're going to do the problems. Now, when we do these more complex problems, there are 2 ways to do the problem. You can separate your numerator and denominator and do your keep, change, flip. Or you can do what I did up here, where you just multiply top and bottom and start canceling stuff out. I'm going to show you both. This is what takes a little bit longer because I'm going to show you both ways. And you can decide when you're working on it which way you prefer. Okay? The separating top and bottom is more work, but if you are a super visual person, you might want to do that. Okay? So what we're going to look at is let's say x squared over 3/2 minus 6 over x. Okay. Now, if we do what we were doing at the top, we're going to find our LCD. What's our common denominators? What do you think it's going to become? 2x. Very good. Super proud of y'all for that. Okay, so your mini denominators are 2 and x. So if I do it like I did up here, then that means I multiply my numerator by 2x and my denominator by 2x. Okay? Now I'm going to cover up that denominator and only focus on one thing at a time. X squared times 2x is what? 2x squared. Now if I look at my denominator, I've got two terms. I'm going to be multiplying this by both. Alright? So imagine one at a time.
How is it?
2x cubed.
Okay.
My bad. 2x cubed. Is that cleared up?
Yeah.
Alright. I know there's not room for mistakes for me to teach this. Okay. So we're going to cover up the numerator, cover up this second fraction because we're only doing one at a time. Okay. If I take 3 halves and I multiply it by 2x, what is going to happen there? The 2's will cancel, leaving me with 3x. Do y'all see that? We all see that. Alright, so I'll write a 3x there. Now I'm going to cover up that other one. If I have a negative 6 over x and I multiply that by 2x, what's going to happen? X's cancel and leaves me with what? Negative 12. Because I'm doing negative 6 times 2. So that gives me negative 12. Can I do anything? I can take out a GCF. That becomes 2x cubed over. Take out the 3. That leaves me with x minus 4. I can't simplify anything with that because that would be my answer. Okay? That's one way to do it. Okay? The second way, and you don't have to write this if you don't want to. This is in the copy of the notes. Okay? If you want to just watch. The second way is to separate the top from the bottom. Okay? My top is just x squared. So I don't need to do anything with that. My bottom is 3 over 2 minus 6 over x. This, if all I'm looking at is this is like my section right before this where I find my common denominator, which is still a 2x, and I multiply by what I'm missing. So here I'd be missing the x. The second I'd be missing the 2, right? This is like what we just did. So then this would become 3x minus 12 over that 2x. Okay, because I would multiply 3 times x minus 6 times 2. And then my common denominator is 2x. So I've got my top and I've got my bottom. So I need to put it back together. So when I put it back together, I have x squared divided by 3x minus 12 over 2x. Well, we know when we divide, we multiply by the reciprocal. We're doing keep, change, flip. So I keep my x squared. I change division to multiplication. And I flip 2x over. I'm going to go ahead and factor that 3 times x minus 4. When I multiply that, that gives me my 2x cubed over 3 times x minus 4, which is what I got up here. Okay? This is more work, but it is more visual. This is less work. As long as you can start covering things up, then you can visualize it. You can do it either way. Okay? Now look at another example. This is a lot. Okay? Let's say we look at 3 over x plus 5. All divided by 2 over x minus 3 plus 1 over x plus 5. Okay, do y'all want to start with this first way, or do you want to start with splitting? First way? Okay. So, if I look at my first way, my common denominators should be what? X plus 5 and x minus 3. Okay? So that means I'm going to multiply the top by x plus 5, x minus 3, and the bottom by x plus 5, x minus 3. Okay? Now that I've written it, I'm going to do all my covering up. Okay? So I've got just the numerator I'm looking at. What happens? What cancels? X plus 5 cancels. So that leaves me with what? 3 times x minus 3. Yes, we all understand that? Okay. Now, to cover up, I don't have enough. Look, I'm going to cover it up with an eraser. There we go. All right. I'm looking at just my first fraction. X minus 3 cancels. Y'all see that? If that cancels, what am I left with? 2 times x plus 5. So I'm going to have 2x plus 10. Now, if you're wondering why did I not multiply the numerator and I'm multiplying the denominator, I know I have to add something else in my denominator. Okay? My numerator I don't. So I could do 3x minus 9, but then I'm going to take it back out in a minute. So if you have 2 terms you're adding, I'd go ahead and distribute it. Okay, do we understand how it came to x plus 10? All right, so now we're looking at the second fraction. X plus 5 cancels, so I have x minus 3. Now I have a plus, so I don't have to worry about anything. If it was a minus, I'd have to distribute that negative. Okay, so I have plus x minus 3. So now I can clean it up. I have 3 times x minus 3 over 2x plus 3x is, 2x plus x is 3x. I'm sorry. And then 10 minus 3 is 7. I can't factor anything out of that. Now notice these 3's are not going to cancel. Why are they not going to cancel? Okay, very good. So here's my answer. All right, now for those of you who are still a little confused, I'm going to separate the top and bottom. You, again, don't have to write this. If you can understand this, you don't have to do the top and bottom part. All right, so my top is 3 over x plus 5. That's just a basic fraction I don't have to do anything with. Okay, the bottom, I have 2 over x minus 3 plus 1 over x plus 5. This makes it a simple problem. My LCD would be the x minus 3, x plus 5. So I multiply this one by the x plus 5. And I multiply this one by the x minus 3. So that leaves me x plus 5, x minus 3 as my common denominator. And then I multiply 2 times x plus 5 to give me my 2x plus 10 plus my x minus 3. So that gives me the 3x plus 7 over the x plus 5, x minus 3. So when I put it back together, I've got 3 over x plus 5 all over 3x plus 7 over x plus 5 x minus 3. So then I do my keep, change, flip, and keep 3x plus 5 times my flip of x plus 5, x minus 3 over the 3x plus 7. I can simplify that x plus 5. There is my 3 times x minus 3 over 3x plus 7. Okay, it is okay if you prefer this one. Yesterday, they all preferred this one. If you're good at covering things up, you can do this one. Whatever makes sense for you. Because you're the one who has to earn your grade. You have to show that you can do it. Okay? Alright. We're gonna try to get like 2 more in. At least. I'm shooting for 3, but that's a little hopeful. Alright, if I have x plus x over 3 divided by 3 minus x over 6. What way do y'all want to do it?
No, split it.
Okay, I'm gonna quickly do both because I have both of y'all wanting things. Okay. If I do the top way, like my first way, I look at my mini denominators, 3 and 6. What's my LCD gonna be? 6. So I'm gonna multiply the top by 6 and the bottom by 6. Okay. And I'm gonna cover up one at a time, right? I have 4 terms, right? I have 2 and 2. So I'm gonna look at just this. Is there a denominator here? No. So I just multiply. What's 6 times x? Alright. Are you okay? Alright. If I do x over 3 times 6, what happens? Yes, the 6 turns into a 2 because 6 over 3 is 2. So then 2 times x is 2. Okay. Now, what do I do? Just 3 times 6 because there's no denominator. So that is 18. 6 cancels out, leaving me with
Negative 6.
We're gonna have to plus that. Don't we have to like the X in the front?
yes, in a minute. Yeah. So do we understand how we got 6x plus 2x over 18 minus x?
Yes, sir.
Okay, if you understand that, feel extra confident in yourself. 'Cause this is a hard section. All right, so 6x plus 2x is going to give me 8x. Now, 18 minus x, like you said, you're going to have to flip this. This is not in standard form. So it should be negative x plus 18. Would I be able to leave it like that? No, I have to take that negative out, and then I never want a negative in the denominator. So I've got my 8x over, take out the negative 1, and that leaves me with x minus 18. And so that negative comes up, negative 8x over x minus 18. Okay. Do we still need to show the top and bottom separated? Okay. It's, I think, in the notes if you want to look back at it. Okay. So then let's say we have six over x minus 5 plus 1 over x, all divided by 3 over x minus 2 over x minus 5. All right, I want you to try to do this. I have confidence in you all. If you want to talk with your person, we can do that. If y'all need to talk through it, I'm gonna give you like 4 minutes. I don't really need 4 minutes, so.
That's good.
If you don't know where to start, what's always your first thing? Okay. What's your LCD? Alright. X times X minus 5. Now finish it. If you got that, then pat yourself on the back, because that's your first step. You can't do anything else without that.
Well, this cancels. So then it's that. So then
This one first. The two different brackets.
Would there be a flag? For this one, since it's in the cancel, it's I'm saying to the two. What do you add on the bottom? Just give them back.
Alright, for time, we're gonna go through it together. Okay, hopefully you did your whole covering up thing. Okay, if I'm looking at my first mini fraction, what cancels? The x minus 5, leaving me with 6x. Okay, then I look at my second mini fraction. X cancels, leaving me with x minus 5. Now, if this was any other number, I'd have to distribute it, but it's just 1, so that's going to leave me with x minus 5. Okay. How do we do on just the numerator? If we didn't, do we see what we did wrong? Alright, so then we got this other mini denominator. X cancels. So I distribute the 3 to the x minus 5. 3x minus 15. If you need to actually write the 3 times x minus 5 before you jump straight to 3x minus 15, that's totally fine. Okay? Do we understand how it became that? Okay. All right, our last one. Negative 2x, so minus 2x. All right. What does my numerator become? What's 6x plus x? 7x minus 5. What's my denominator? Can I do anything? Who got that on their own?
Oh, something.
Or like you were on the tap there and you felt good about it.
Yeah.
I'm so proud of y'all. Okay. So, we don't have time for another one. Do you feel like you have at least a good chunk of it? Like you're 70% understanding it at least?
I understand it perfectly.
Okay. Oh, good. Okay. So,